The simplified rate transient analysis workflow, which was introduced in David Anderson's Distinguished Lecturer Tour, which was hosted about a year and a half ago, is presented here. Here we can see it broken into 4 basic categories. We start with diagnostics, or what a lot of others would call data diagnostics, which is just looking at the empirical trends of the data, trying to see if we can capture some simple takeaways for flow regimes and productivity issues. It's very nice because you can look at the data with a very large well count and you can extract some basic information that would be of value to reserves and even to, as reservoir engineering goes, being understand basics about flow regime transitions. Then we get into the interpretation component and analysis. By analysis, I mean the analysis techniques are also very practical in the fact that they can be applied quickly to a large well count. These would include straight line methods like square root time plots or specialized linear flow plots that use more sophisticated time functions, and type curve techniques, and also flowing material balance analysis. So these are a combination of straight line analysis methods and type curves. The modeling and history matching component to follow, this is where we spend the bulk of our time, quite frankly, particularly in complex multi-phase fluid environments, which seems to be very popular these days, particularly in the Permian. We spend a lot of time either doing analytical or numerical modeling. We do this to validate the interpretations from our analysis. In that sense, the results from analysis are the feedstock for our initial iteration for our models. And once we get a very good history match or a set of series of different reservoir descriptions with good history matches, which we can either do deterministically or probabilistically, we then take those with a characterized reservoir and we do our production forecasts. Forecasts that are rolled up into economics packages to generate cash flows and to really understand the optimization of the field.